Oh, you gotta find them.
I caught a smaller one. I caught like 15, 20 pounder hits.
All right. Let's look at it. Okay. I don't want y'all doing horrible. Okay, so first off, if you remember the question that was here in black, I did that really quick in second period. I'll be posting that video along with this video later on, as long as nobody says I'm stupid. I will be posting it, so you can go looking for it. I'll send it to you and remind. But please understand, in second period, we got pushed for time, and I didn't have time to break down how to calculate the molecular mass of these different molecules. You should, by this time, be able to calculate the molecular mass of a molecule. If you cannot, God touch their grades. So first thing you got to do is find out what you're starting with. So the first thing is, before you can move anywhere past this, you have to get a chemical equation. So in this case, in the combustion reaction of C6H16, if you started with, I don't need to go any further than that. I'm starting with C6H16, and it's a combustion reaction. So in this case, I have C6H16, and it's a combustion reaction. In combustion reactions, you have hydrocarbons. Here's your hydrocarbon, and oxygen react to produce carbon dioxide and water. Now we just have to worry about balancing it. You must have a properly balanced formula. So we're going to start it off. Carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. I got 6 carbons on the left, 16 hydrogens on the left, and 2 oxygens on the left. What I got on the right? 1 carbon, 2 hydrogens, 3 oxygens. Easy as 1, 2, 3. Alright, so remember back whenever we're balancing these reactions, first thing we're going to do is balance everything else besides hydrogen and oxygen, and when we leave oxygen for last because it's sitting by itself and makes our life a lot easier. So let's balance the carbons. I got 6 carbons over here. I need 6 carbons over here. I only got 1, so what number I stick in front of here? 6, because 6 times 1 is 6. So I get 6 carbons. The only issue is it changed my number of oxygens as well, because oxygen is in there. So 6 times 2 is what? 12. How many oxygens I got? 13. Nice. I thought I was going to trick you. There's 13 because here's 12, but you still got this 1 oxygen sitting by itself. That is, covering up the top of the eye there. Alright, let's move to hydrogen. I got 16 hydrogens on the left. I need 16 on the right. So, where's hydrogen? Right there in water. What number I put here? 8. So I now have how many hydrogens? 16. And is that it? No. Speak with confidence, people. No, it's not. Oxygen has changed because the oxygen is sitting in there. So what do I have? 20, yes. Because we have 12 here and 8 there. So, let's balance the oxygens now. I have 20 oxygens on the right and I have 2 oxygens on the left. This is how I do it. I take the number I have here on the right and I divide it by 2. Why? Because oxygen is a diatomic, so it's automatically bonded to itself. And I get 10, so 10 goes there. Are we balanced? So we're good. Okay? In second period, I gave them one where this didn't work out so nicely like this. Like when you do this division here, it gave you a decimal, which a decimal is a fraction. And then we multiplied all the coefficients by 2 to get rid of that. Alright? Now, we'll erase all this, and it's time to make a plan. You don't ever do anything without a plan. You first got to have a plan. Okay? The first piece of information for your plan is where you're starting. 789.6 grams of C6H16. So what am I starting with? Yeah. So I'll go and write that down. I know that's what you want me to do. Set over 1. Now this is the thing. I'm wanting to go from here, and I'm wanting to go to how much carbon dioxide. So I want to end there. But the key to it is I need grams of carbon dioxide. And I have grams of C6H16. Now here's the problem. And a lot of people, I understand, you're wondering why do we have to go to moles first? And this is why. You can't just go straight from grams to grams, because think about it. Grams is a unit of mass of how much something weighs, but moles, if you remember back, moles is how many of something there is. It's a count. So if I looked at you and I told you that I give you a 5-pound bowling ball and 5 pounds of feathers, they both weigh the same, right? Which one of these two is there more of? The feathers. So it's kind of like if I looked at you and said, you know, how much does a 5-pound bowling ball weigh? How much does 5 pounds of feathers weigh? The answer is 5. But if I looked at you and I asked you for the count of how many of those items there are, how many bowling balls? 1. How many feathers? A whole stinking lot. Okay, feathers are not heavy. So that's why we got to get to the mole. The mole is the count of something. So we're going to use information. We're going to get to moles of C6H16, and then we're going to get to moles of CO2, and then we can get to grams of CO2. And there's pieces of information here. I should have included this in second period. Hopefully they watch the video. When we're going from grams to moles, you're going to use molecular mass. Hopefully it makes sense now why what I said earlier, you know, hopefully you can calculate molecular mass. And then to go from moles to moles, you're going to use the mole ratio. That says ratio. I know that looks like horrible. Okay. And then we go from moles of carbon dioxide to grams of carbon dioxide, you're going to use the molecular mass. Okay? How's everybody feel? So in this case, I already know I need the molecular mass of the C6H16. I'm going to calculate that. Molecular mass of C6H16 is carbon, hydrogen. You get 6 carbons, 16 hydrogens. What's the average atomic mass of carbon? 0.01 grams per mole. Hydrogen, 1.01. And I don't know what they are individually. I calculated it if they were together. So 72.06 and 16.16. These are grams per mole. Grams per mole. Add them together. Gives you 88.22 grams per mole. So now you can start making some conversions with this, because now, look where we're starting. Grams of the C6H16. We're going to go to moles of C6H16. So 1 mole of C6H16 I won't be left with moles. I got to get grams to cancel, so grams of C6H16 goes on the bottom. What numbers is going to go here with this grams? Yes, both of y'all did the pencil point. 88.22. So grams of C6H16 cancel. It's like nobody wants to speak. I'll point my pencil. That number. Alright, so now we are done here. We've made it to this point. We're in the moles of C6H16, so let's keep moving on. I want to get to moles of carbon dioxide. So it means mole of carbon dioxide is on the top. I need moles of C6H16, cancel. Alright, what number goes up here up top? Nope. What do we use here? The mole ratio, right? Where do you get the mole ratio from? It is a 6. Where's the mole ratio come from?
6.
The 6. So the coefficient, that number in front of these molecules. There's a reason you balance this thing first, and it's because right here. If you did not balance this, you would be wrong. So what goes here with moles of C6H16? What number's here? 1. Was that simple and easy?
Yeah.
It was number 1. Okay? Whatever number is up there goes with it. Now, we're here. Moles of C6H16 is gone. I'm so happy I can stop saying that now. Then we got to get into grams of CO2. So I got to use moles of CO2 on the bottom to cancel the moles of CO2 out. So 1 goes with the bottom, but what goes with the top number? What goes with the top? Molecular mass. Yes. What is the molecular mass of CO2? That's that hurt the ankle. I grilled my ankle the other day, and it's just the way I just stepped on it. It just really hurt. Yes. How do you figure out the molecular mass?
Jordan Vance, come to the office. Jordan Vance.
Booty off now.
If we can calculate that and get 44.01 grams per mole. And remember, that number always follows grams. So now, we are ready to punch into a calculator. I'm going to go step by step with how I'm punching this in the calculator. Because I know people are punching things wrongly in the calculator and nobody has the guts to say anything about it. I turn on my calculator. I press the on button. It's located right here in the bottom left corner. I hit the clear button because I don't want all those numbers to confuse me. And then I put in parentheses 7, 8, 9.6, and I end my parentheses. The reason I do that is I like to use parentheses. Okay, so I go from here to here. Is there a number here in the top I need to worry about? Now there's the number 1. I don't have to put times 1, but you can if you want. You're going to end up with 789.6. Then I got this number in the bottom. It is in the bottom. So will I multiply or divide by it? Divide, so I'm going to hit the divide button. It's right there on my calculator. And then I will punch in 8.22, and I hit enter. And I did this to try and check myself. I get 8.950351394 moles of C6H16. Now with that, does that number make sense? Yes, my moles should be lower than my grams. So we're doing good. Yes? Okay. Now, I just did this one. No longer mathematical stuff coming from there. But let's move here. So what do I do now? Multiply by 6. Now, with leaving the number I have pressed enter in my calculator, I hit the times button. It's the edge next to the 9. It means multiply, and I press the 6. Okay. Now, do I need to divide?
No.
No. Because it's 1. Anything divided by 1 is itself. Yes? Very nice. Now, from here, we're done with this. Bada boom, bada bing. What do I do now? So I push the times button yet again, and I push 44.01, and I put enter. Now whenever I do this, I put enter equals, sorry. I was going from calculator mode to I'm on the board mode. Equals, and I write my number out, 2,363.429. I pause. For my fourth number, I look behind it. I have 2,363.42978. And that 8 tells me I round my 7 up. So it means that this is now 8. And I put my units. Why? Because your units matter. And Mr. Hall will take off half credit if you do not push your units. Yes? Very nice. Grams of carbon, right? Yes, carbon dioxide. And then you put the box around it and say, there you go, Mr. Hall, in your face. You thought you were going to fail me. In your face, I'm better than you. And then you're done with that. And you're done. There's the answer. Questions? This is your time to ask.
How much time do we have? Do we have time for another one?
No.
You have 1 minute, so no.
So you're not doing anything with the
Well, tomorrow.
No, water does not matter. The water is just there. If I wanted to ask you for the products, then yes, you would do something with water. But in this case, I said carbon dioxide, so you worry about the carbon dioxide. Because we care about the polar bears, yes? Not really. Those things are ferocious. You ever watched anything on the Discovery Channel on those things? They're like, the quiet, majestic polar bear stares at you like a cute, cuddly teddy bear. And once you open the door and reach out to pet it, it rips your arm off and eats your heart out. Very vicious.
The only thing I've seen
Absolutely. Let me get out of it though. I don't want no pictures.
So is tomorrow our last full chemistry class?
That's it. You'll be done.
No, that's
Then you can sign up for physics.
Okay. They go.